Winter was breathing down your neck. Sure, you'd stocked up on firewood and grain. But when the first snowflake would actually deign to fall was anybody's guess. So, the chores had to be done, namely that blasted wall, and that pile of rotting weeds and tree roots down by the East River bank, just begging to be turned into paddy fields next year. Just as you were counting down the days till hibernation, that rascal Yufu finally rolled in with his caravan. 2,000 head of livestock, you wouldn't believe it. The place looked like a bloody zoo. Half the tribe, those with nothing better to do, flocked to gawk like they'd never seen an animal before in their lives. You had to admit, the guy had some serious pull. Yufu, ever the smooth operator, insisted on dragging you and the tribal elders out to inspect the spoils, the highlight being your personal assessment of the livestock breeds. You squinted at the sheep, not bad, size-wise. About like the domestic sheep you remembered. The color, though, white as cotton candy. On closer inspection, a whole lot of gray. Digging deeper, you realized there were two types of sheep. Pure white and those with black heads and tails against a white body. Variety is the spice of life, you thought. The rams sported curly horns, while the ewes were bald as coots. You reach out and stroke the wool. Whoa, not the stiff, armor-like stuff you expected, but soft and fluffy as a cloud. You vaguely recalled a news story about a sheep that went AWOL for 6 years. 6 years without a haircut, its wool had matted into solid lumps, hard as rocks and weighing hundreds of pounds, turning it into a veritable woolly monster. Alas, these sheep were clearly domesticated. Their wool regularly harvested for felt. You sigh. Guess you wouldn't be seeing a real-life woolly monster anytime soon. Next up, the cattle. Now these were different from your tribe's forest cattle. Those were dark brown, with forward-pointing horns. Like Spanish fighting bulls, these grassland cattle were lighter in color, mostly yellow, some with yellow and white patches. Their horns curved upwards and slightly backwards. They were also smaller. The forest cattle could reach 2 meters at the shoulder. These, maybe 170, 180 tops, but the main event, the moment you'd been waiting for, was the horses. These steppe horses made zebras look like overgrown donkeys. Average shoulder height, about 160. Zebras were thickset, with short heads, stubby necks, and short legs. These beauties had long heads, flared nostrils, long necks. They looked powerful, with long legs, broad shoulders and backs, and deep chests. These were proper horses. You knew it in your gout, meaning great lung capacity for sucking in oxygen, and big hearts to pump blood to those powerful limbs. These were built for running, both fast and far. You were seriously impressed. All in all, a damn fine deal. You couldn't help but commend Yufu. The kid was sharp as a tack. Best of all, most of the 2,000 animals were female. The population of Han village was about to explode. After the livestock inspection, Yufu presented you with a wild man named Ling, along with his family, and 10 girls from the Altai tribe. He even made a point of highlighting Ling's talents. Chief, this is Ling. We found him on the steppe. He was banished from his tribe because he has red eyes, but he's incredible, a fantastic rider, and a marksman to boot. I saw him shoot ducks out of the sky while riding. 1 arrow each time, never missed. He's also a dog whisperer. Trains them to help with herding and even to retrieve arrows. I think he's a treasure. None of our warriors can ride and shoot. If he could teach them, that would be amazing. You have to keep him. Did he even need to ask? You might be a crack shot, but that was on foot. Horseback archery, forget about it. Your expertise lay more in driving cars and tanks. Riding and shooting was definitely not a skill you had unlocked. Now you had a ready-made riding instructor drop right in your lap. Only a fool would pass that up. Red eyes be damned. You didn't buy into those superstitious tall tales. Good. From now on, you're one of us. You'll have everything everyone else has. No one here will discriminate against you. I hope you can contribute to the tribe and teach others what you know. Your name is Ling, right, now that you've joined Han Village? You need a Han Village name. Ling will be your surname. I'll give you the name Feng. From now on, you'll be called Ling Feng. You clap Ling Feng on the shoulder in a gesture of approval. Through Yufu's translation, Ling Feng understood everything. The chief had accepted him into the tribe, had even given him a name, and promised him the same treatment as any other member of Han village. Everything that they had, he would have too. Ling Feng was overcome with emotion. He'd been driven from his tribe, forced to wander. No other nomadic tribe would take him in. But you hadn't looked down on him, hadn't discriminated. You'd treated him like your own, without hesitation. Ling Feng dropped to one knee, swore fealty, and promised to devote himself to the benefit of Han village. After meeting Ling Feng and his family, the 10 stepgirls were quickly dealt with. You simply had them moved into a house specifically for the livestock farm. You had Dashu show them the house, distribute supplies like animal skins and pottery, and teach them how to use the house, how to heat the Kong beds, and how to cook. They had already learned some of this on the way back, as Yu Fu had taught them the basics. Ling Feng and his family walked down the brick road in the city, looking at the towering warehouses and the rows of neat houses. They felt like they'd stepped into paradise. This was civilization, compared to the nomadic tribes. They were barbarians, nothing like this grandeur, this orderliness, and when Dashu explained that everything here was thanks to you, the chief, Ling Feng's admiration grew even more. Although you were young, you were clearly brilliant, capable of managing thousands of people so well, and ensuring they lived a life of abundance. He knew he couldn't have done it himself. Hey, look. Ling Feng's family was quickly taken to an empty house. The tribesmen were as enthusiastic as if they had been injected with chicken blood, dizzily coming and going to offer their help. Some of them huffed and puffed as they brought water jars, buckets, pottery, and animal skins. The woman next door quickly spread animal skins on the Kong, a traditional heated brick bed. The men pushed a small cart and fetched 2 bags of rice from the warehouse, and there were also those who pulled a flatbed cart to deliver firewood. Hey, all the necessary tools were also in place, including axes, carrying poles for fetching water. And everything was there. After the Kong was spread, Ling Feng's wife and children sat on it. The enthusiastic neighbor started the teaching mode, showing them how to work around the cooking stove. 2 pieces of flint for starting a fire were brought over. Hey, but it turned out that they weren't used at all. Someone directly pulled out a burning piece of firewood from their own home and lit the fire. The Kong heated up quickly, and this made Ling Feng's family so amazed that their eyes were as white as copper bells, and their faces were full of wonder. The men pulled Ling Feng to the well at the intersection to fetch water and chattered on, telling him that he should get water from here in the future, that the water jar at home should be filled with water every day, and that he should chop more firewood when he had nothing to do, just in case. As for you, after you went back, you asked Zidai to send some linen and woolen cloth to their home, and you specifically explained that it was prepared for the children. You thought to yourself that since the cloth was in short supply now, it could only be given to the children and the high-ranking members first. Most of the adults still wrap themselves in animal skins. You mused that the new life had both its advantages and disadvantages. Take Ling Feng's sheep, horses, and shepherd dogs for example. They were all taken over by the public. It was okay for the sheep to be taken over, but Ling Feng and his horses were as close as wearing the same pair of pants. Now that they couldn't see each other often, Ling Feng's heart must be itching like a cat scratching at it. You were also worried. How could you keep horses in a residential house? And you couldn't temporarily delegate the horses to private individuals. There was no other way but to promise Ling Feng that he could go to the livestock pen to take a look at his precious horses when he was free. And those shepherd dogs were simply a headache. They recognized their master, and they dashed joyfully towards Ling Feng's home. You spread your hands, looking helplessly, and could only tell Ling Feng to take good care of them and make sure they didn't bite anyone. It would be best to find a way to send these dogs to the farm. But you also knew that it would take time to get used to the new environment. Anyway, the winter was long, and you didn't have the leisure to keep an eye on these trivial matters every day. You had more important things to do. Well, the iron pot casting mold developed by the carpentry team was completed. You looked at this thing. Goodness me. It was a wooden frame structure as a whole. There was a wooden box at the bottom, and the shape of a pot was made with refractory soil inside. On top, the wooden frame was like the bones, the rattan was like the flesh, and the clay was like the skin, forming a pressing mold, which was also connected to a wooden rod that could be pressed down manually. To put it simply, it was to build a skeleton with wood. Install a rattan-woven pot, and then paste a thick layer of refractory sole outside the rattan, and polish it smooth to serve as the inner wall mold of the pot. When casting, pour the molten iron into the earthen pot below, which was the outer wall model. Then press down the lever to lower the inner wall mold. Combine the upper and lower parts, leaving a flat shape of the pot in the middle, and then just wait for the molten iron to cool naturally. In addition to this iron pot cast-in mold, there were also some pointed iron anvil molds made by the lost wax method, as well as a large number of iron ingot molds. The crucible for holding molten iron was even more particular. It was a large bucket cast with bronze, with a layer of refractory sole pasted on the inner wall, and then it was fired in a kiln together. It was so big that a person could crouch inside. The crucible was equipped with a special small flatbed cart, with solid oak wheels at the bottom, which had a strong load-bearing capacity. There was a bronze lifting ring on one side of the crucible, and on the other side, there was an extended notch for casting, which was like the spout of a teapot, making it convenient to pour out the molten iron. There was also a lever copper tube on the side of the lifting ring. After the crucible was filled with molten iron and transported to the casting position, a long wooden bar could be inserted into the copper tube to extend the lever arm. Then the people behind could press the lever to tilt the crucible and pour out the molten iron inside. Everything was ready, and there were enough people. On the first day of winter, there was no one left in the market. It was on this day that you led the tribesmen to start smelting iron. In front of the huge star-shaped blast furnace, Da Zui was as agile as a monkey. He climbed up the shelf beside the blast furnace, threw a pile of lit firewood inside, and then threw in a lot of dry firewood, first igniting the fire in the main furnace. The 4 auxiliary furnaces around also started to light fire simultaneously. After the fire was lit, you stood there like a commander, directing the tribesmen to add charcoal with the gantry crane. The rattan-woven hopper was like a hot air balloon basket, with 4 pulley ropes hanging on it. More than a dozen people pulled the ropes together, lifting the basket to the height above the furnace top, and then pulling the entire gantry crane along the wooden track to the furnace mouth. After that, the 2 ropes of the basket close to the furnace mouth remained still, and then the 2 ropes at the back were raised, tilting the entire basket and pouring the whole basket of charcoal into the main furnace. Since the auxiliary furnaces around were lower than the ground level, charcoal could be directly added from above with a small cart. Finally, the lids of the auxiliary furnaces were closed, and the hot air inside was directed to the heat storage chamber. The flames in the auxiliary furnaces were burning fiercely, and the temperature in the heat storage chamber was rising steadily. Under your command, the main furnace continued to be charged. After adding several baskets of charcoal, it was almost 3/4 full. Then it was time to add ore bricks. 1 basket of ore bricks, half a basket of charcoal, and then pour in a basket of limestone as a reaction accelerator, which was helpful for slag formation. Finally, fill the furnace with charcoal again. After the main furnace was fully charged, by this time, the auxiliary furnaces had been burning for a while, and the temperature in the heat storage chamber was already very high. You waved your hand and ordered the 4 blowers to start. The blowers were between the heat storage chamber and the main furnace. It was a closed brick-built pipeline. Inside, there was a 6-bladed fan made by inserting copper sheets into a wooden shaft. The wooden shaft extended to both sides of the pipeline and was connected to a linkage crankshaft. The final power output was to pedal-operated wooden machines. This thing looked like a fitness treadmill in a park. There was a handrail in front and 2 pedals below. As long as a person stood on it and stepped on the 2 pedals back and forth, they could drive the fan to rotate. Moreover, the fan of each blower was operated by 2 people, who stood on both sides of the pipeline and stepped on the pedals facing each other. The pedal-powered blowers were much better than the hand-pulled bellows. They were much more labor-saving. Standing there and stepping on the pedals was just like doing fitness in the park, and when people were tired, they could be replaced. The air volume provided was not only sufficient, but also uninterrupted. Even when people were being replaced, 1 person would be left at each blower. People could rest, but the blowers couldn't stop. The 4 auxiliary furnaces were burning charcoal desperately. The outer wall of the heat storage chamber was already too hot to touch. 8 people operated the 4 blowers, continuously blowing high-temperature air into the main furnace, increasing the oxygen content in the main furnace and accelerating the temperature rise and the reaction speed. After about half an hour, you peeked into the furnace through the observation port and then asked someone to continue adding charcoal inside. The high-temperature air ejected from the air inlets in the main furnace made the temperature in the furnace chamber rise steadily, and soon it reached the melting point of iron. When the charcoal burned, it reacted with the oxygen in the air to form carbon monoxide. When it passed through the iron ore above, it absorbed the oxygen molecules in iron oxide and turned into carbon dioxide, which continued to rise until it was discharged from the furnace mouth and became black smoke. The oxygen molecules in iron oxide were taken away by carbon monoxide, turning it into elemental iron, and because the temperature was higher than the melting point, the elemental iron melted into molten iron under the influence of its own gravity. It slowly settled to the bottom of the hearth. The limestone inside mixed with the impurities, sintered, melted, and finally turned into a liquid alkaline slag, floating on the molten iron and sinking into the hearth together. When the hearth was filled, it was time to open the furnace and release the iron. The furnace had been roaring for hours, fed relentlessly with charcoal and blasted with superheated air. The iron ore within finally surrendered, melting completely into a pool of molten iron. The slag, too, liquefied and floated to the surface, leaving the furnace almost empty, everything else having been refined and sunk to the bottom. Big-Mouth, wielding a copper hook, pried open a protruding firebrick in the furnace wall. Revealing a small peephole, he squinted inside, then turned to you, eager to report. "Chief, it's all clear up top. Should we add more?" You sauntered over for a peek yourself, feeling that the crucible down below must be full. You started issuing instructions again. "No more ore. Let's tap the iron, get the drainage channel set up." "Slag first." "Yes, Chief." Big-Mouth spurred into action, rounded up a few men. Though this was the Han tribe's first iron smelting, Big-Mouth had been intimately involved in building the blast furnace and understood its workings and principles. Lacking only practical experience, besides, this whole operation, involving so many people and such massive equipment, had been rehearsed countless times. Everyone knew their role and bustled about with surprising efficiency. While the blower still huffed and puffed, work was already underway before the slag tap was even opened. A cartload of green bricks was pushed forward, and a makeshift ramp was erected beneath the tap. Another group hauled 3 sections of semi-cylindrical clay pipes and positioned them on the ramp. One end of the piping faced the slag tap perfectly, while the other led to an earthen pit a few meters away, the slag repository. This slag might be considered waste, but cooled. It was perfect for road-based material, or even brick making. Waste not, want not, as they say. Once the piping was set up, Big-Mouth and another man, each armed with a copper hook, removed a brick from the upper side of the furnace. In an instant, bright red, viscous liquid slag gushed forth from the opening, the slag, glowing a fierce red, dillowed with heat. After flowing a meter or two down the pipe, the top layer began to cool, slowly turning black, like pumice floating on lava. By the time it reached the earthen pit, it had mostly solidified. After a while, feeling that most of the slag had been drained, you gave the command to tap the iron. Men swiftly wheeled forward a bronze crucible cart and parked it firmly in front of the iron tap, wedging the wheels with broken bricks to prevent any accidental movement and a potentially disastrous splash of molten iron. Big-Mouth once again used his hook to pry loose a firebrick from the iron tap. A rectangular opening appeared, and a stream of orange iron flowed into the waiting crucible. Everyone stood back several meters, keenly aware of the dangers of the superheated metal. You stood beside Big-Mouth, wanting to delegate the entire process to him, and took the opportunity to offer some pointers. Big-Mouth, the most important thing in smelting iron is controlling temperature and timing. We can't measure temperature yet, so we have to judge by the color of the iron. Watch carefully. Remember every step of the process, what color the iron is. Next time, you'll know what to do. Yes, Chief, I got it. Big-Mouth nodded enthusiastically, convinced of your deep knowledge of this magical science. He focused intently on the molten iron, trying to memorize its color. All right, no need to stare so hard, you'll burn your eyeballs out. Just remember the color, you said, noticing his goofy, wide-eyed expression. It was all well and good, but with no eye protection. Staring at molten iron was a surefire way to damage your eyes. Asterisk, gotta make sure this caveman doesn't ruin his peepers. Asterisk, you thought, with a mental eye roll. After a while, the iron was completely drained. The furnace now truly empty. The bronze crucible was full to the brim. Not a drop wasted. The dimensions of the furnace and the amount of ore added had been calculated with precision. Now that no new hot iron was flowing in, the temperature of the molten metal began to drop, shifting slightly towards orange red. Though the change was subtle, iron, you knew, absorbed heat quickly, but dissipated it slowly. It wouldn't solidify rapidly. You ordered a cart of refined iron or powder to be brought forward. Men grabbed wooden scoops and began adding it to the crucible. Scoop, scoop. Big Mouth picked up a stone pestle with a wooden handle and stirred the mixture in the crucible. This was the stirring the steel stage, of course. You had no idea what color indicated real steel. You were just aiming for wrought iron, so you allowed them to add or powder to their heart's content. Within reason, they'd stir, add a scoop, and repeat. When the bright yellow iron had turned a ruddy red, you called a halt, any more, and you feared the temperature would drop to low and affect the casting. You ordered them to wheel the crucible over to the molds. First up were 2 anvil horns, the essential blacksmithing tools. If they had nothing else, they had to have anvils. Once the 2 anvil molds were filled, they were wheeled aside to cool. Then, others brought the cast iron pot molds. Big Mouth fetched 2 large ladles made from crucibles to scoop the iron. 2 strong men took the ladles, each scoop carrying upwards of 15 pounds of molten metal. Ladling iron was grueling work, not for the faint of heart. A ladle of red-hot iron was poured into a mold. Its color quickly dimmed. The men operating the press slammed down the upper half of the mold, which had concave and convex surfaces. The iron was squeezed, and the pot shape appeared almost instantly. The compression also drastically increased the surface area, causing the temperature to plummet. And the iron began to solidify into a dark red solid. The pot was formed. Eager tribesmen flipped the mold over and dumped a still-cooling iron pot onto a patch of soft sand to cool naturally. The process repeated endlessly. A line of iron pot pressing machines worked relentlessly, 2 burly men shuttling back and forth, pouring ladles of iron into each mold. The molten metal in the large crucible was rapidly depleted. There were 2 sizes of pots, large and small, both custom designed for the Han tribe's hearths, hemispherical, with a 3 centimeters wide horizontal rim that would sit perfectly on the fire pit. The pot walls were about 4 or 5 millimeters thick, with the larger pot weighing around 15 pounds and the smaller one weighing just under 10. Once the pots were completely cooled, they'd be filled with sand and polished smooth using a shovel in a circular motion. The bigger the furnace, the higher the iron yield. Naturally, good heavens, dozens were directly involved in the iron smelting, and hundreds more provided support. Each firing produced around 2 tons. Aside from casting 2 anvils weighing over 100 pounds each, the rest was all made into iron pots. After the final count, there were barely 200 pots, big and small combined, not even enough for your own Han tribe. But everyone was thoroughly exhausted from the day's work, so they had to call it quits for now. You instructed the tribe members to continue polishing the iron pots and told Big Mouth to inspect all parts of the furnace for damage once it had completely cooled down, repairing any broken areas promptly to prevent future accidents. Big Mouth readily agreed, having spent the whole day monitoring the iron smelting. You felt utterly drained, so you decided to take a solitary stroll. You wandered slowly to the irrigation river, where the water level had dropped considerably in the early winter season. However, the watermill by the riverbank was still turning, although not as quickly as before due to the reduced water flow. You entered the mill and inquired about the output of iron or powder with the tribesmen working inside. Learning that the accumulated storage should be enough for another 2 firings, you finally felt relieved. These tribesmen rarely saw you in person. Seeing the chief arrive, they couldn't help but say a few extra words, praising how good the watermill was, how miraculous, and so on. You merely smiled. The watermill was indeed very useful, especially in the south with its abundant water and ice-free conditions, allowing it to operate year-round. But here in the Han tribe, it was different. in another month at most. The river would start to freeze. At that point, using the mill would be out of the question. As you left the mill, a cold north wind picked up, making you shiver involuntarily. You quickly tightened the animal skin clothes you were wearing. Hey, thinking of the wind, you suddenly had a flash of inspiration. Water freezes in winter, but the wind is strong. If you could build a windmill, wouldn't it be able to work in winter too? Besides, wind, as a natural power source, is available all year round. Even more convenient than a watermill, at the very least. You wouldn't have to worry about location. A watermill is useless away from a river, but a windmill could be built anywhere. As long as there's wind, it can operate, especially in winter. Having come up with a solution, you immediately rush back to the carpentry group. You found 2 long wooden sticks, crossed them, and tied them securely with rope. Then, you fashioned 4 square frames from rattan and asked someone to fetch 4 burlap sacks from the warehouse to cover the rattan frames. Making 4 fen blades, the carpenters, watching your strange actions, understood that the chief was up to something new again. But they still couldn't figure out what this odd contraption was for. Until you mounted the cross-shaped fen onto a horizontal wooden frame, the fen blades, facing north, were soon set in motion by the wind. But after a few turns, it fell to the ground. You placed the fen back on its frame and tied it down with rope. The fen started turning again, albeit crookedly, but it kept spinning nonetheless. This left the entire carpentry group wide-eyed. Is the chief planning to put this thing on a machine, driving gears to make something like the watermill? Daryl was the first to grasp your intention. The others were still baffled, but Daryl's explanation helped them quickly visualize such a device. They couldn't help but admire your ingenuity. They were blown by the wind every day. How could they not think of that? That's right. Our watermill will be out of commission in less than a month. The river will freeze in winter, and the mill will be unable to work. But the wind is strong in winter. If we can harness that wind power, we can continue to do many things. That's why I came up with this. I made this thing specifically for you to see. You've already participated in building the watermill and know how gears work. Now that you've seen this, you should understand what I mean, right? You explained to them. The chief's wisdom is unmatched. He can even think of something like this in the future. We'll not only be able to use natural water as power, but we can even use the invisible line. Something driven by water is called a watermill. So should something driven by wind be called a windmill? Beryl said with admiration. Exactly. It's a windmill. It's good that you understand the principle. I'll figure out the detailed construction method as soon as possible, and then you'll be the ones to build it. You'll have to learn carefully. I think this windmill, if built well, will definitely be better and more versatile than the watermill. After all, this thing just needs wind. It doesn't have to be built on the riverbank, you said matter-of-factly. Yes, that's true. Ignoring weather factors, windmills are also more advantageous than watermills. Watermills can only be built by water, but most natural rivers aren't suitable for building watermills. Digging artificial canals would be time-consuming and labor-intensive. Building windmills is obviously more cost-effective. Stake chimed in. Yes, exactly. All right. You all go back to what you were doing. I'll go back and think about how to make this thing. And I'll tell you when I figure it out. After speaking, you went home alone and laid down on the warm con bed. The room was quite dim. The windows and doors were temporary additions, made of wooden planks for the door and animal skin wrapped around rattan strips for the windows, blocking out most of the sunlight. The Han tribe didn't even have paper yet. Making a translucent window was difficult. Thinking of this, you couldn't help but sigh deeply. Alas, the future is long, and your responsibilities are heavy. There's a whole bunch of things waiting for you to do. You can't rush these things. You have to take it slow. In the following days, you led the metallurgy group in smelting to more furnaces of iron, exhausting the materials accumulated over the previous months. However, you also obtained many iron ingots and a small amount of steel ingots made using the cementation process. The number of iron pots was also sufficient, after meeting the Han tribe's own needs. You had dozens of iron pots left as reserves or for use as trade goods. The majority of the iron was stored as iron ingots, temporarily putting aside the study of iron. You soon plunged headfirst into the carpentry group. Over several days, You led a group of carpenters in making a windmill model as tall as a person. The model was small, but it had everything it needed. The drive shaft, transmission shaft, and wooden gears were all meticulously calculated and scaled down proportionally. With the new project launched, the Han tribe's carpentry group didn't have enough manpower. And because there wasn't much to do in winter, many tribesmen were idle. You began recruiting a second batch of carpenters in the tribe to produce more wooden products. In addition, with iron available, professional blacksmiths were also being selected. The Han tribe's cultivation of technical talent was gradually unfolding. Hey, this windmill invention is truly significant for our Han tribe. Practically a revolution, its uses are endless. It's not just for grinding flour, frankly, it's a way to provide power. What it's specifically used for depends on the actual situation. Take, for example, iron forging. That's tiring work. You're constantly hammering away with big and small hammers, and once you start, there's no end in sight. It's incredibly exhausting. But if we had an automatic forging hammer, it would be much easier. Look, they invented the hydraulic forging hammer back in the Western Han dynasty. What we want to do now is simply replace the hydraulic power with wind power. However, this is not a device that can be built in a day or two. Right now, to forge iron, we still have to rely on hammering, and the Han tribe doesn't even have a blacksmith yet. So you'll have to personally teach the first batch. You don't have to worry too much about the carpenters. The Han tribe already has quite a few, and the newly joined tribesmen have to start as apprentices, temporarily only responsible for sawing wood. Once the iron forging project started, a blacksmith shop was quickly built next to the blast furnace. It was just a temporary shed made of bricks and logs, which would have to be moved once the wind-powered forging hammer was built. But don't underestimate it. It has everything it needs: a brick-built furnace, a wooden bellows, a chopping block made of logs with a 100-pound cow horn anvil on top, plus 2 iron hammers, a quenching trough, and several copper tongs. Basically, that's it. The blacksmith apprentices were also in place. Several wild men who had previously joined the Han tribe. One of them, a fellow named Yi, was the one whose arm you set the bone for. He later followed Big Mouth to learn copper smelting. And now he's come to learn iron forging from you. Now that we have wrought iron and steel, you plan to be the first to forge a weapon for yourself, a longsword. Swords have existed since ancient times, reaching their peak in the Han dynasty. But that was also when swords began to decline. It wasn't that the sword's performance was bad, but the cost was too high, making it unsuitable for mass deployment. So it was quickly replaced by the saber. After all, being a straight blade, single-edged is much less time-consuming and labor-intensive than double-edged. What you want to make is the most typical Han dynasty's 8-sided Han sword. The name comes from the cross-section of the sword, which is a flattened octagon, meaning the sword body has 8 sides. The biggest feature of this sword is that it is relatively thick, upright, and unyielding. It can be used for thrusting and slashing. And it is very flexible and not easily broken, which is also a characteristic of the Han sword. However, these characteristics depend on the materials to make the blade flexible. You have to use wrought iron to make the sword blank and finally clad the edge with steel, so that the longsword can be sharp and unyielding. You personally selected a piece of wrought iron, put it into the furnace to heat it up. The apprentice next to you immediately pulled the bellows to make the iron ingot soften faster. After burning for a while, you clamped the iron ingot with tongs and hammered it on the anvil. You wielded the hammer, and you hammered with the sledgehammer next to you, each hammer closely following your landing point. You hammered once, and he followed with a hammer, slowly stretching the iron ingot, then folding and forging it. To maintain the flexibility of the sword blank, it was not folded too many times. Only repeated 3 times, which is ready for use. 1 time becomes 2 layers, 2 times 4 layers, and 3 times 8 layers. This number of folded layers is suitable for wrought iron, and any more than that will easily break. The final hammered sword blank was a foot long and quite thick, which is of course not the final form, but only a prototype. After the sword blank is made, steel must be clad on the edge, because the sword is double-edged. 1 piece must be clad on each side. After a steel ingot is heated red, it is hammered into a thin strip, then placed on the edge of the anvil and hammered into 2 sections. Then folded and forged separately to make 2 angle steels. and then put into the furnace with the sword blank to heat up. When cladding steel, sprinkle some borax on the bonding position first to remove oxides and impurities on the metal surface so that the metal can be better connected. Then wrap the two angle steels on both sides of the sword blank to form an I shape, after repeated hammering and stretching. Finally, hammer the sword body into a long strip shape with a blade length of 108 centimeters. The thickness of the sword spine is about 1 centimeter, and the width is about 3.5 centimeters, which is narrow in the front and wide in the back. The sword head is about 3 centimeters wide. The sword hilt is a slender flat iron with 3 round holes opened on it. And finally fixed with copper rivets, the handguard part of the sword, that is, the sword pavilion, is the boundary between the sword blade and the sword hilt. The handguard of the saber is called the saber pool. The names are different, but the functions are the same. The sword pavilion of this lawnser is made of copper iron tin alloy, cast by the lost wax method, and engraved with wandering dragon patterns. It can be directly put on the sword hilt and installed during the final assembly, after the lawnser is formed. It cannot be quenched immediately. It must be roughly polished while the sword body is not particularly hard, so that the sword body is polished into the desired shape, and then quenched after the final shape is set to increase its hardness, and then finally polished, that is, the final edge opening. This is not something that can be done in a day or two, since the sword body was formed. You have polished it at home for 5 or 6 days. To this end, you also specially cast a vernier caliper with bronze to measure the data of various parts, and finally polished a longsword that is symmetrical up, down, left, and right. After the sword body is roughly polished, it is quenched. But note that earth covering and burning blade technique is not required here. Earth covering and burning blade is to make the hardness of the blade and sword body different by different cooling times. But this is a longsword made with a steel cladding process, which has already achieved this purpose. So just quench the whole sword directly, after quenching. Finally polish to polish out the sword's edge. And finally assemble, put the sword pavilion on the sword hilt, and then put on the sword handle. The material of this sword handle is too luxurious. It is made of the only ivory in the Han tribe. It was broken off the Grey Mountains moth by the mandrill, and later picked up by you and kept it, until now, waiting to be used to make the sword handle for the weapon. The sword handle is an oval cylinder with a hollow interior, carved with patterns on the outside, and 3 holes are drilled in the corresponding parts. Glue is applied and inserted together, and then the 3 round holes are riveted together with copper rivets, and the sword is made. This sword is very long, and the sword handle is also relatively long, which is suitable for holding with both hands, making it easier to exert force when slashing. And the center is a palm's width in front of the sword pavilion, and it is also flexible to wield the sword with one hand, making it particularly handy to pick up as a precious sword symbolizing the chief status. This sword must have a resounding name: Wrath of the Emperor. The Emperor's wrath brings millions of corpses, and blood flows for thousands of miles, symbolizing absolute kingship and dominating the life and death of the world. The sword name is engraved on the sword body in front of the sword pavilion in official script, and decorated with copper liquid to make 3 golden characters. Although the process is troublesome and luxurious, this is your sword. And it is not excessive to be luxurious. After all, it is a symbol of status and must not be the same as ordinary goods. Hey, the Wrath of the Emperor sword you crafted has a scabbard made of black ironwood from the Tree tribe's original settlement. This black ironwood is extremely hard and has a dark color. You simply glued 2 long strips of wood together and secured them with copper rings. You might notice that this Han sword scabbard has belt loops, which didn't exist in the Han dynasty. Belt loops weren't invented until the Tang dynasty. Before the Tang dynasty, all swords either had to be held in hand or directly inserted into the belt, making them very inconvenient to carry. Later, in the Tang dynasty, swordsmiths began to attach belt loops to the scabbard, allowing swords to be hung on the waist, freeing up both hands. Modern TV dramas are too careless, not paying attention to these details in the props, creating a bunch of incongruous things and misleading many people. Although you're making a Han sword, you're not stupid. Clearly, there's more advanced technology available. So why not use it and make things difficult for yourself? Therefore, All swords produced by the Han tribe in the future must have belt loops. The tribesmen didn't have much of an idea about iron weapons. They had only heard you say that iron weapons were better than bronze, that they had never seen exactly how. You had no choice but to take out the wrath of the emperor to demonstrate for them. First of all, the most important thing is toughness, which bronze weapons don't have. You specifically had someone bring 2 bricks from the city wall, place the sword on top, and then stood on the suspended blade yourself. Good heavens, the blade was directly bent into a large arc that as soon as you lifted your foot, the blade whooshed straight again, startling everyone around and making their jaws drop. Next was to test the sharpness. You couldn't exactly test it by cutting someone, so you had someone bring a sheep over and then swung the sword to chop off its head. The sword shadow flashed swoosh, and the sheep's head flew off whoosh, with a gush of blood spurting far away. The spectators were once again shocked. The sheep's fur was so thick, yet it was beheaded with one strike. If it were a bare human neck, the outcome would probably be even worse than the sheep's. Chief, how can this iron sword be so powerful? If our warriors all had one, I bet one person could fight 10. Ratty said with a look of astonishment. Yeah. Chief, can we have a sword like that too? Digtree asked eagerly. He was one of the earliest chiefs to follow you, making him the most qualified to ask this question. In fact, this was the question everyone was most concerned about. Such a good weapon, almost worthy of being called a peerless divine weapon. Who wouldn't want one? Probably not. I saw the chief spending a month making this sword with a few people. If our tribe all used this kind of sword, it would take forever. The elder, who had watched you make the sword, was more knowledgeable and poured cold water on everyone. That's right. Swords are indeed difficult to make, however. You former chiefs will have them in the future. As for the remaining ordinary warriors, we can only equip them with easy-to-make sabers. That is, weapons with only one blade. As for other tribesmen, whoever wants a sword must make great contributions to the tribe, and I will reward them with a precious sword. But don't look down on single-edged sabers. I've already had someone make a sample of a ring pommel saber for you to see. The overall performance is not inferior to Lonsword's. It just lacks a blade. But this is safer for people who don't know how to use swords. After all, it's easy to hurt yourself if you don't use a double-edged sword well. Hey, ye, bring the ring pommel saber we made and show it to everyone. You explained the sword allocation issue, wiping the blood off the blade, and finally asked ye to bring the finished ring pommel saber for everyone to see. This straight saber, though called a ring pommel saber, is completely different from the Han Dynasty's ring pommel saber except for the iron ring on the hilt. Instead, it looks more like a Tang Dynasty's straight saber. In fact, you really did make it according to the Tang Dynasty straight saber's craft. Some people may ask, aren't ring pommel sabers very powerful? Why make Tang Dynasty straight sabers? It depends on how you compare them. Ring pommel sabers were indeed very awesome in the Western Han Dynasty. They were made by folding and forging with 100 refined steel, and the blade angle was small, making them very sharp. In that era, they were definitely unrivaled divine weapons. But ring pommel sabers also have many shortcomings that need to be improved. Before the Han Dynasty, no one used sabers. It was only during the Western Han Dynasty that single-edged sabers began to be made. So, ring pommel sabers are the ancestors of later sabers. But they are also very primitive and crude. Ring pommel sabers, to put it bluntly, are just bare iron strips with a blade. They don't even have a blade shoulder, making them speechless primitive. It is easy for the enemy to attack the hand holding the saber during a duel, which is a fatal problem, a major defect in shape. In addition, the raw material of the ring pommel saber was historically made of 100 refined steel. But that is just a single material. In terms of performance, it is not comparable to the composite layered steel process of the Tang Dynasty straight saber. And there is no earth covering and burning blade technique either. To really talk about the pinnacle of sabers, it has to be the Tang Dynasty straight saber. Your ring pommel saber is made using a layered steel process. The blade uses 2 pieces of wrought iron, and a strip of steel is sandwiched at the edge. The blade head is also the geometric blade head unique to the Tang Dynasty straight saber. During quenching, earth covering and burning blade was also used. The finished product has both toughness and sharpness. combining all kinds of advantages, and it is easier to make than a sword, making it most suitable for mass deployment. The entire blade is 85 centimeters long, which is considered a relatively long short weapon. The hilt is slightly longer, so it can be held with one hand or two hands. The weight is also appropriate, and the center of gravity is relatively forward, which is particularly conducive to chopping. The back of the blade is particularly thick, a full 1 centimeter thick. The angle of the edge is also very distinctive. It is not as small as the edge angle of the Han Dynasty's ring pommel saber, but the blade is thinner than the Tang Dynasty's straight saber on both sides of the blade spine. There are also two inward recessed blood grooves. Speaking of this blood groove, it must be emphasized that its function is not to bleed or to send air into the wound. Those are all rumors. The real purpose of the blood groove is to strengthen the blade body, play the role of a reinforcing rib, and make the saber less likely to break. The material of the handle is an oval made of softwood, without carving, but wrapped in a layer of pearl fish skin bought from the fork tribe. This pearl fish skin has high friction and elasticity, making it most suitable for wrapping the handle, which can greatly increase the comfort of the palm. The blade shoulder is also cast with bronze. This is something that the ring pommel saber does not have at all. You specifically added it to make the hand holding the saber safer and less likely to be cut by the opponent. The tribesmen quickly took this ring pommel saber and tested it one by one according to the method you tested. As a result, they found that, just as the chief said, the ring pommel saber was not inferior to the Han sword at all. It was even more prominent in chopping ability. Some people even preferred this ring pommel saber a little more. Hey, the first month of winter flew by, and although our Han tribe only produced one saber and one sword, other construction progressed rapidly. Take the rammed earth city walls. For example, rammed earth is a simple and practical technique. The earliest city walls in our country were all made of rammed earth. For a pure rammed earth wall without brick cladding, 80 people can ram out a 6-meter height, 800-meter long wall in 7 days. The speed of construction is astonishing. However, that kind of wall is different from ours. Their walls are only a little over a meter thick. The difference in workload compared to ours is huge, so our construction speed isn't as exaggerated as theirs. Our Han tribe city has sides of 400 meters, which includes the wall thickness. The original plan was a base width of 4 meters, a top width of 2 meters, and a height of 5 meters, using soil dug from the moat, but after you calculated, you found that the soil was not enough. Also, the base width of the wall was twice the top width, making the wall angle too gentle and not very conducive to defense. To balance these issues, you changed the wall to a base width of 3 meters, a top width of 2.5 meters, and a height of 7.5 meters during construction. You made these changes to use less earth and to increase the verticality of the wall. When enemies attack the city, climbing the wall is more difficult, which indirectly increases the wall height and expands the wall top area. More people can stand on the city wall or place large defensive equipment, such as heavy weapons like ballistae. About 200 slaves and some warriors are involved in the construction of the Han tribe's city wall, but they are not very familiar with building this kind of structure for the first time. Fortunately, you invented the ramming car, which slightly increased the construction speed. After several months of efforts, the city wall finally reached the capping stage. The wall is said to be 7.5 meters high, but the actual rammed earth height is only 6 meters. The remaining 1.5 meters has to be paved with a layer of 20 centimeter thick bricks, leaving only 1.3 meters, which is the added parapet from the outside. The highest point is 7.5 meters, but in reality, it is only 6 meters. The parapet is used to protect the warriors on the wall. Now the construction progress is that the rammed earth height is enough, and they are laying the top floor tiles and building the parapet. There is a city gate in the middle of each of the 4 walls. The city gate is 3.5 meters high and 3 meters wide. A vertical rectangle. There are 3 gates inside and outside. 2 double-opening solid wood doors that are 10 centimeters thick, and a 30 centimeter thick solid wood drawbridge outside. After the drawbridge is raised, it sticks to the outer city wall and can also be used as a door. Above the city gate is a gate tower, which is also a gate fort. The gate fort is not large, only 5 meters long. the same width as the wall top, 2.5 meters, and 4 meters high. Only one story. 2 winches are installed inside to raise and lower the drawbridge. The entire gate tower plus the gate fort is 10 meters high. Inside the city gate on both sides, there are also stairs close to the city wall. The stairs are 1.2 meters wide, which can accommodate to people walking side by side. Even if someone goes up and down at the same time, they will not be blocked because it is too narrow, making it convenient for warriors to quickly go up and down the city wall. You were overjoyed when the city wall was capped. This tall city wall can bring a full sense of security to the tribe. The tribesmen also cheered. Living in such an indestructible city, they are proud and happy. They don't worry about food and clothing. And they are not afraid of foreign enemies. In this era, it is simply like living a fairy tale life. As the city walls gradually took shape, most of the tribesmen who had nothing to do also joined the construction team. They eagerly looked forward to the early completion of the city walls. Except for some women who were already pregnant and women who stayed at home to take care of the children. The remaining tribesmen all devoted themselves to the final capping work, moving bricks and building parapets. The newly joined apprentices in the carpentry group also found suitable wood in the lumber yard to make gates and drawbridges. Their work enthusiasm was very high. Participating in urban construction made them feel particularly accomplished. You didn't idle either. You found limped and worked with him to customize 8 super large green bricks with embossed official script fonts. The words Hanyang are placed directly above the first city gates, which is the name of the first city of our Han tribe, Hanyang City. The name, first, represents that this is the city of the Han tribe. And second, it is taken from the meaning of the sun, symbolizing the supreme status of the Han tribe, and also the implication of the rising sun. Our rapidly developing Han tribe is like a rising sun, and it will definitely become higher and stronger in the future. After another 10 days, in mid-February of winter, all the construction of the city walls was finally completed, including the stairs, the gate forts, and the drawbridges and wooden doors on all sides. In a month and a half, there was only one heavy snowfall, and the snow depth in the city square was only 10 centimeters, which was not as big as the 2 snowfalls last year, and did not affect the construction process of our Han tribe. After the city walls were completely completed, you arranged new tasks for the 200 slaves to continue building warehouses and breeding farms. Although it was very cold, you were not soft-hearted towards these former man-eating aliens. Anyway, they are all slaves. It would be a waste to keep them without using them. Moreover, although you forced them to do hard labor, the benefits they should get were not deducted. Each of these slaves has an animal skin that can wrap their whole body, 3 meals a day, and enough white salt. Although there is not much meat for them to eat, they can still drink the meat soup as much as they want. In this cold winter, it is also a happy thing to drink a bowl of steaming hot meat soup. They did not have this treatment in the original cannibal tribe. So these slaves are also quite obedient and honest. Anyway, they have food to eat if they work, and they will be beaten if they don't work, and they can't escape. Especially after they built the city walls themselves. There are people guarding each city gate, even without shackles. It is impossible to rush out of the city gate. This tall city wall is a haven for the people of our Han tribe, but for these slaves, it is an insurmountable cage. In a month and a half, the windmill of the carpentry group was also prepared. 2 sets were made in total, which can be installed on a building as big as a warehouse. This windmill has 4 fan blades. Each fan blade is 1 meter wide and 5 meters high. When it is not covered with burlap, it looks like a huge ladder. In fact, it is almost the same. People can really climb up along the fan blade skeleton. The fan blades will be covered with 1 meter wide burlap, and pulleys and ropes control the raising and lowering of the burlap. Just like a sail, when the windmill needs to rotate, the burlap is raised to catch the wind, and when it is not needed, it is lowered. The empty fan blade skeleton cannot catch the wind, and the windmill stops rotating. The first windmill house was built next to the blast furnace, with 2 windmills installed on top. One provides power for the forging hammer, and the other provides power for the stone mill, so that the Han tribe can continue to grind or powder in winter. The cold wind was frolicking on the ground, and many tribesmen of the Han tribe were shivering in the cold wind and came to watch these two windmills, the big windmill, chirping and squeaking. The scenery here is really beautiful, the sky is beautiful, the earth is beautiful, and there is a group of happy little friends. Cough, cough.
Wow, Mom, look, that windmill is turning so fast. The chief is so awesome, he can actually make this kind of thing.
Cubing, wrapped like a plush toe, jumped in front of the windmill and shouted to his mother.
As you are still young, in the future, you have to learn more from the chief. Then you can help the chief. Maybe you can study something yourself. Mom knows that the chief rewards the tribesmen who invent things very highly. If you can make something powerful in the future, you may be able to wear that kind of tin crown and be a captain or something.
Cubing's mother rubbed his head and encouraged him.
Yes, I know. The chief teaches us to learn Chinese characters. I study very hard. The chief has praised me for being smart. I will definitely be as powerful as the chief in the future.
Cubing said with a serious look, his small eyes full of confidence and fighting spirit. The windmill ran for 2 days, as steady as can be, without any failures. The tribesmen also gradually calmed down from the initial enthusiasm, and only some children who had nothing to do would occasionally run out to take a look. As soon as the trial operation ended, you immediately issued an order to continue building windmills. This time, it was the same 2 sets of windmills, that they were built for the carpentry group, which is the Han tribe's lumber mill. Relying on the power of windmills, several wind-powered sawing machines were made, which could greatly speed up the production of wooden products and free up more low-level manpower from the carpentry group, allowing those apprentices who could only saw wood to do other things. The structure of the sawing machine is not very high precision. It uses a crankshaft to turn the circular motion of the windmill into reciprocating motion, driving the saw blade back and forth to achieve the purpose of sawing wood. Here, it must be mentioned that the saw blades of the sawing machine are all made of steel, and they are long saw blades of the same specifications, not circular saws. Why? Because to make the speed of the circular saw reach the speed that can saw wood, it is difficult to rely on the windmill plus the gearbox, and the vibration amplitude of circular motion will definitely be large, and flat wood cannot be sawed at all. So you finally decided to use the saw blade that moves up and down. There are 4 sawing machines. Each windmill drives 2. 2 of them are specially for sawing wood boards. A vertical tool holder is installed on each side of the windmill main shaft. This tool holder is a frame shape, which can be vertically installed with a large row of saw blades, and the spacing distance of the saw blades can be adjusted according to the thickness of the required wood boards. The linkage device of the saw blades divides all the saw blades into 2 groups, A and B, which are installed alternately. When working, one group goes up and one group goes down. As long as the logs are pushed into the tool holder, what comes out from the other side is wood bore, which saves a lot of effort. Only 2 or 3 people need to watch the machine and send wood into it. The other windmill is connected to 2 single saw tables, which are divided into upper and lower layers. The lower layer can cut off thick logs, and the upper layer can be used as a table saw to make some special wooden strips or wood squares, and can also be used with a ruler to saw shapes with specific angles. Of course, there is a reason for building this wind-powered lumber mill first. The residential houses of the Han tribe still don't have doors and windows. Why? Because no one has the time to saw so many wooden strips. That after this processing plant is built, basic wood can be produced quickly. Then, whether it is making furniture and decoration, or building ships and vehicles, or engaging in wooden machinery, the Han tribe can quickly process it. You ordered a group of blacksmiths to make saw blades, and guided the carpentry group how to make sawing machines. Soon, you got busy with other things, which was making all pressing equipment. The Han tribe has stored so many all fruits, but there is no pressing equipment to produce them yet. Seeing that there are more and more wooden products, but tumal, which is used as paint, is still nowhere to be found, so the research and development of pressing equipment is also on the agenda. The process of vegetable oil pressing is basically the same. First, grind the fruits containing vegetable oil into powder, then fry them in a pot, then wrap the fried powder with cloth or straw bags, and finally physically press to squeeze out the oil inside. In this process, the most important thing is pressing, to have a high oil yield. The pressure us be strong enough. To increase the pressure, there are two ways. One is to increase the weight and increase the pressure. The other is to reduce the stress area and increase the pressure under the same weight. With this simple physics knowledge, which was learned in junior high school, you use it with ease. The pressing equipment was built in a new warehouse built by the slaves, and you named it the oil mill. The oil mill is divided into 3 areas, which respectively process 3 kinds of vegetable oil. One is peanut oil, the second is tung oil, and the third is lacquer fruit oil. Similarly, each area has independent stone mills, furnaces, stoves, frying pans, and oil presses. Although it looks wasteful, it is safe. After all, tung oil is poisonous, so you can't use the same set of equipment as peanut oil. In addition, although lacquer fruit oil can also be eaten, its seeds grow on lacquer grass, so lacquer fruit oil has other uses, such as oil for ink. Using this lacquer fruit oil with other ingredients, you can make special ink for printing books, which is more important than tung oil and peanut oil. The structure of the pressing equipment is also simple. First, cast a bronze vertical cylinder with holes at the bottom and a diameter of 40 centimeters with bronze, and then use giant wood to make a lever-type pressing hammer on it, which can be lifted and lowered with ropes and pulleys. And bricks can also be hung on the giant wood to increase the weight of the pressure arm, so that the oil pressing workers can flexibly grasp the pressure. In late February of winter, while you were guiding the tribesmen to build oil mill equipment, the gloomy sky began to snow again. The snow fell for a whole day, and the snow depth in the city square was a foot thick. Such a heavy snow is nothing to the well-prepared Han tribe, but it is too difficult for those small tribes with only dozens of people. Food is scarce, and fuel is also scarce, forcing them to go out. In previous years, when they encountered this situation, they would usually go out hunting to get through it, but this winter they have a new choice, which is the Han tribe's market. Although they don't know if it will be open in winter, they only know if it is there by seeing it in person. Maybe this is the hope to survive.